Jeffrey. That was exactly what we were hoping for in terms of some of the larger framings of these issues. Our next speaker is Pierre-Olivier Pineau, who is a professor in the Department of Decision Sciences at HEC in Montreal, and has held the chair in energy sector management since December 2013. As I mentioned, he's the co-investigator in our project to do these workshops. He is an energy policy and management specialist with a focus on electricity reforms. His research focuses on electricity market integration and on optimal approaches to balance energy production and consumption. He's worked in Canada, Africa, Latin America, and the Nordic countries, and has published papers on all of these regions. He sits on the board of directors of the Canadian Association of Energy Economics as well, so he's eminently well qualified indeed. When this conversation began about who should we talk to in Quebec, who deals with energy and electricity issues, it became very apparent very early on that all roads led to Pierre. that he was the person we needed to talk to, and that has very much proven to be the case. And I think he's going to be sharing some of his recent research on the energy situation in Quebec and also the potential for exports.
Thank you for coming again. I recognize some faces I've seen in May when I came here for the first workshop. So I made sure no slide I'm showing today was already there in May. At least all the slides are new. The message is still the same. I'm still convinced that integration is good for Quebec, for Ontario, for Canada, even for North America, and especially in terms of electricity. There's a huge potential. So what I'm planning to do is basically, well, talk about these benefits. I think there's more knowledge to gain on what are these benefits. In theory, they're well known. I think this topic is understudied because any economic in any economics department would say, well, of course, integration is good. We should have a free market, and benefits are obvious. So as it's obvious, we should not discuss them further because they're obvious. But I don't think it helps to make the policy case to politicians. If you just say the benefits are obvious, then they go to voters and they may not find these benefits obvious. And I think especially, well, in Quebec, people don't see that it's obvious to sell electricity at a higher rate, and it will be good for them. It would be good for citizens in Quebec to pay more for electricity, but that's true. It's not obvious to see why. Yeah. So I'll make a small introduction with some data, because I think some very basic data are very important to have in mind. They're not new, but when we see these data, we start realizing there's something wrong about the way our systems are designed. So I'll go through some data that is hard to get because we've mentioned that in Quebec, sometimes it's hard to deal with Quebec. It's even the Quebec government. Even for us Quebecers, it's hard to deal with the Quebec government and with Hydro-Quebec. So I'll show you some data I'm quite proud to find. With Ontario, that would be obvious. You just go to the IESO website and you get the data. In Quebec, you have to look hard and work more. So I'll show you some data, and then I'll go through some results of two of my forthcoming papers on the benefits of harmonizing pricing across Quebec and Ontario, and ending the provincial self-sufficiency dogma, which is something that we are all suffering from. So if we look at Ontario and Quebec in terms of capacity, what's installed? So there's hydro in both provinces, much more hydro in Quebec than in Ontario. It's known, but you can see, as a reminder, there are 13 million people in Ontario and 8 million people in Quebec. So the population of Ontario is quite bigger, larger than the Quebec population. So that gives a proportion of the scale of hydro capacity in Quebec. Then we both have wind, about the same numbers, and it's still developing in Ontario and Quebec, but it's comparable. Then you have in Ontario some solar power, then of course nuclear power, which is very important, more than 10,000 megawatt, and then some thermal power. And that's about it. You have also about in thermal power, it's included all the natural gas. Some coal is still included because these are 2013 data, and biomass power plants. So in the end, 42,000 megawatt in Quebec, 31 or 32,000 megawatt in Ontario. That shows the scale of the generating capacity in Quebec. There's a huge capacity to produce power in Quebec. It is significant, and it is, as we will see, it's not well utilized. Now, in terms of production, so how much terawatt hour do we produce? 205 terawatt hour in Quebec, 145 terawatt hour in Ontario. Then what is sold within the province, if we look at the sales within the provinces, again, Quebec with its 8 million people buy more power than Ontario with its 13 million people. And of course, there are two main explanations for that. It's industries. Because of the low rates in Quebec, we have many large industrial users that are using a lot of electricity. But the second explanation is electric heating. We do heat our homes with electricity in Quebec. That's a huge proportion of our electricity usage. That is mostly nonsense in terms of how you want to use hydropower. There would be huge gains to be made if we were heating in a better way our homes. So there are lots of technical gains to be made in the Quebec systems by just rethinking how we consider heating and temperature in homes. But what is even more concerning from an economic perspective is that you see Quebec dominating here, but don't worry, Ontario is much better at extracting money out of that smaller amount of electricity sold within Ontario, because if you look at the value of the provincial sales in Ontario, $13 billion in 2013 and only $11 billion in Quebec in terms of the value of the revenues generated by these provincial sales. And basically, if you look at the price per kilowatt hour, the average revenue in Quebec is 6.5 cents per kilowatt hour. The average revenue in Ontario is 11.5 cents per kilowatt hour. That is almost like if Saudi Arabia decided to sell oil at its production cost while the market price was even $50 now or $100. Saudi Arabia doesn't sell oil at the production cost. We do in Quebec sell most of our electricity at the production cost. It doesn't make any sense. It's been like that for many years. We're not alone in that nonsense. Manitoba, I mean, even Ontario is selling hydropower at the production cost. Manitoba is, and BC is. In the States, it's even worse because most of the hydropower in the U.S. is federal hydropower, and not even do they sell hydroelectricity at the production cost, but they don't allow these federal entities to make any profit on their hydropower, on federal hydropower in the U.S. We do in Quebec and Manitoba and BC do have some profit margins on the cost, so we do extract some rent, but marginal rent. So it doesn't make any economic sense. It should be clear that the situation has to change. And if you look at these numbers, it should be clear that Quebec would make better money selling to neighbors, among them Ontario, and Ontario would make a better deal at paying less from someone who could provide electricity at a lower price. So that's these numbers, I think, should be repeated, and I'm repeating myself in every talk on this topic, on showing these numbers, because I think they speak for themselves. Now, if we look a little bit more technically at the load and hourly load in Quebec, you'll see for 2013, the hourly load in Quebec, and these are numbers that are not easy to find, and I'm happy to display them. So you see, it starts on the left in January 1st at midnight. So it's the winter, it's cold, and it wasn't cold only in 2013. This year, January 1st, 2015 was also very cold. So you see the load is very cold during the winter, and then we enter a spring, load decreases, and for the summer we have a few months of load that are about lower than 20,000 megawatts. So out of the 40,000 megawatts that we have in Quebec permanently, during 4 or 5 months, we only use 20,000 because there's internal load is very low. And then, of course, falls come and fall comes and the winter comes, and then we start heating again. Most of these load fluctuations are between months are mostly explained by heating. It's not the industrial load across the year is stable. Commercial load is stable. It's really the heating. So it's really a heating. We have about 20,000 megawatts that are just there to heat homes, which again is a nonsense. You know, home could be better designed. There would be better heating systems for homes. So there's basically 20,000 megawatts in Quebec available for whoever offers solutions. It cannot be developed, you know, in a year, but it can be developed relatively quickly when we look at the horizon of that we should be looking at in terms of planning. 10, 20 years, 30 years, there's 20,000 megawatts already installed that could be shifted towards other things without new constructions. Of course, there would be policy shifts to be made, governance shifts to be made, but there's capacity available in the medium run. And then if we compare that to Ontario, so the red data is hourly load in Ontario, very easy to get at the IESO. Something so we should have in Quebec, some open space for data. We don't have that open space for data in energy. But what we see is that the peak load in Ontario is during the summer. So there are obvious gains to be made here. And I'll have, so that's basically the basis, the rationale for the recent agreement between the two governments. When in November, when the Quebec government met the Ontario government, they made an announcement that 500 megawatts of peak load would be provided by Quebec during the summer and provided by Ontario during the winters as an exchange to basically make better use of the unused capacity during the summer. So during the summer, Quebec stands at less than 20,000 megawatts of capacity needs, and so there are 20,000 megawatts sitting there without any use, and they could be used in Ontario. I have a better slide to show that. So here we see this is the maximum load, the maximum monthly load in Quebec. So here we have aggregated monthly data. So you have the 12 months of the year. This is the maximum. This is the average load for every month. And this is the minimum load in Quebec for every month. So what is interesting here is to compare to the maximum load in Ontario. And here you see the maximum load in Ontario for all these months. And the maximum load in Ontario is above the Quebec load, the maximum Quebec load for about 4 months, again, the summer months. So these are the months where really Quebec, Ontario could really benefit from the spare capacity, the idle capacity that is in Quebec. And so that's, again, the rationale for making some collaboration. So we can continue with these graphs, but there's no new message there. Just for the pleasure, I drew other drafts, looking at hourly maximum and average loads for every hour of the year. So these are the 12 months combined. But this is just for my own pleasure. There's no new lessons to be taken from these data. When you get data you wanted for many years, then you start playing with them. And these data from Hydro-Québec, it's the Régie d'Énergie, the energy board that made Hydro-Québec publish them on PDF files. So it was a 50-page PDF file document that I had to basically send to a student so that he didn't retype everything, but he took the PDF and translated that to an Excel file, and then we had to work on the data. But it's just to show the level of collaboration within Quebec. I mean, it's a stupid story, this data story, but if you can't get the load, the hourly load from the Quebec system easily, where can the policy discussion go? I mean, to make some kind of third-party analysis. So it shows the kind of work we have to do. And just in terms of explaining these gains, and because Hydro-Québec, we invited Hydro-Québec to sit in our panel here today, and it took 2 months to basically say, no, sorry, we can't come. They didn't even say sorry. No, we can't come. But they even took 2 months to say no. They could not immediately say no directly. So what can be done with this situation, with the nonsense I show you in prices? Collaboration on peak hours, we can say, well, I wrote done. It's not totally done, actually. There's an initial agreement for 500 megawatt of collaboration. It won't be in place before 2016, so it will take time to actually materialize, but there are some discussions and already some plans to have some collaboration. So that's great. But I think we should, just think about going much further into rethinking our electricity system. So basically, the 2 points I want to explain, and this is based on 2 papers, one that is forthcoming and then another one that is still a working paper. We should stop selling below the market value, the electricity market price. We should stop selling below that market value in Quebec. So that would be good for Quebec, and it would be indirectly good for Ontario and all the neighbors, because we would have more power more energy to sell to our neighbors. So I have a paper that is there. It is accepted in the Energy Journal. It won't be published, it told me, before 2016, because they have too many good papers to publish, and ours is easily in the chain. If you're interested, I can give you, of course, a PDF file of that forthcoming paper. And what we're doing, basically, in that paper, we're taking Ontario and Quebec, and we are trying to compare the current situation with 2007 data, which I know is very different from the current situation in Ontario. But the basic lessons are the same. So we take the current situation, and we compare with the market. So we model the situation, the 2 markets, and say, well, if Quebec sells at the market price, what happens? So we have a model of the 2 markets, hourly model of 2007 markets on Ontario and Quebec, and we just compare in terms of who's producing at what price, how much is sold, what are the emissions, and we can just, I'll show you the results. I'll spare you the details of the model, but as I said, if you are interested in the model, it's all well, it's not yet public, but you can ask me and I'll give you the full paper. So price results. So we are working with 2007 data and with the limited transmission capacity that we have between Quebec and Ontario. So it's about, at that time, it was about 2,000 megawatt of capacity. So limited transmission capacity. And what we want to show basically is that, of course, so you see a lot of results. Just concentrate on what I've circled in red. You see the TH stands for thermal for Ontario. So there's one thermal jurisdiction, and then the other one is a hydro jurisdiction. It's Quebec. So we have Quebec and Ontario. And we see the price slightly going down in Ontario because of additional imports when we have a market pricing in Quebec. And of course, due to the limited transmission capacity, the price in Quebec cannot go as high as the Ontario price, because there's a limit to, there are congestions on the transmission lines. So basically, the price in Quebec only slightly increased by $3 a megawatt, which is a third of a cent per kilowatt hour. But we see a price increase in Quebec and a price decrease in Ontario. So consumers in Ontario basically would be happy, and consumers in Quebec wouldn't be happy, but producers in Quebec would be very happy about making more money. The good thing about all that is that we can prove, and that's a proof in the paper, that the overall consumption goes down. So some people say, well, yes, well, if the price goes down in Ontario, there'll be more electricity consumption, and then it is true that it will slightly increase, but in Quebec, the reduction will, the consumption will decrease because of the higher price. And we can prove, and it's shown, that here we have a global reduction in consumption. And the beauty of that is that while you reduce consumption, you increase welfare. So there are welfare improvements in the system. Globally, everyone is richer because of the price, the change in prices, while there's a lower consumption in electricity overall, especially in Quebec, of course. So it's a case where we get richer, we decrease consumption, and emissions go down. In our model, emissions go down by a little bit more million tons than it would now, because there was, in 2007, there was still coal in Ontario, so our hydro would, well, Quebec Hydro would replace some coal, but now it would replace, of course, the marginal units, which are natural gas units. So basically, some hydro will replace natural gas, and there would be decreases in greenhouse gas emissions in Ontario with this kind of export. And there would be imports in Quebec from Ontario during the nights, as they are now, and they would be mostly nuclear imports, so there wouldn't be increase or marginal increases in greenhouse gases in Ontario due to additional trade. So if we look at, and I think that's a key point in the political economy of the problem, if you look at the numbers here, the consumer surplus in Ontario goes up by $275 million. So these are the savings made by Ontario consumers in our model. And these savings, they basically rip off Ontario producers, because Ontario producers would lose, of course. They would lose market share from the imports from Quebec. So what consumers in Ontario would gain, producers in Ontario would lose that. And that, of course, in the political economy has to be taken into account in how we think these kind of changes. Now, the big changes in Quebec, consumers in Quebec, they lose by $275 million because they pay a higher price. But Hydro-Quebec makes a lot more money than what Quebecers would lose. They make, if you look at the change, Quebecers produce, Quebec consumers would lose $550 million, but Hydro-Quebec would make $600 million more in the process. So basically that would mean Hydro-Quebec could compensate and send checks to every Quebecer for whatever amount, the additional amount they've paid, and Hydro-Quebec would still be richer at the end of the day. And that's why globally it's better for the society, that you can compensate everyone and you still have money left on the table because you've organized the system in such a way that you generate more wealth. And the beauty of that is that you reduce greenhouse gases and you get a negative abatement cost for your emissions, because in the process of reshuffling prices, you export more hydro to Ontario. In my model, that is a substitute to coal and natural gas. Now it would be a substitute to natural gas. But whatever reductions you get, you generate more wealth and you get a negative abatement cost. We think reducing greenhouse gases costs something. It actually provides more wealth to our society. The exact same argument could be made between Alberta and BC. So this is not just a Quebec-Ontario thing. It's an Alberta and BC dialogue that should also get and start, because Alberta is in the same situation as Quebec, and BC is in this, well, not exactly the same, but it's kind of similar situation with a neighbor with high prices and selling in BC at low prices, relatively low prices. Manitoba and Saskatchewan, or Manitoba and Ontario, would be in the same situation. So this is not a unique Quebec thing. It's a Canada problem. And of course, as Hydro-Quebec has the most of the largest hydropower capacity, it's, you know, the problem is mostly in Quebec, but it's also spread all over Canada. So these are basically the results of the model. The message is we can get richer, decrease emissions, and be all better off, although there are some political economic questions to be solved, because consumers in Quebec, they're really hard to convince that it's better for them. There would be ways. I'm working on different projects to see how they could accept higher prices. I think in my idea, at the end of my life, if I've succeeded, then I'll be happy to, you know, have contributed to some progress. I've been working on that for more than 10 years, and some of my colleagues 10 years ago were saying, well, why do you work on that? You know, that's nonsense. I mean, it will never happen. Political obstacles are too big. And say, well, if people in universities don't work on that, who will work? Because I have time. You know, I don't care. I'm a tenured professor. I can, as long as I publish papers, you know, I can say these things, and people will laugh at me and invite me in conferences, and I'll have a good life. Telling them you should pay more for electricity. Well, I'll tell you should pay less for electricity in Ontario, and in Quebec, I'm telling them you should pay more. So now the other, and I'm almost done, but I still have some interesting results to share with you. This is still a working paper with a colleague, Kathleen Vaillancourt, consultant, who's working with Markov times models, bottom-up, extremely detailed models of the energy systems in Canada. This is a methodology that is used worldwide. There are consultants doing, there are teams working on Canada, but teams working on world models or different countries. So it's a very detailed. Every consuming sector of the economy is included in the model. Every power plant is there. It includes gas, oil. All the energy system is there. So we focus on electricity, but one of the constraints in this model is that when they model Canada, they model 10 different provinces, and they have one constraint, is that each province should have enough capacity to meet the peak load of its province. So that's a constraint in their current model. That's just a line in the model. And the constraint is, well, Ontario has to have enough capacity to meet its peak load, and Quebec has also to have enough capacity to meet their peak load, and so on for every province. And why, so we decided with talking with Kathleen, well, can you lift that constraint, and can you just look at what if the constraint is just that nationally we have enough capacity to meet our national peak load? That would make more sense. I mean, of course, from a constitutional perspective, it's a provincial matter, and we don't disagree with that. But at least technically, we can just look at the result. So we have some preliminary results. There are some gains, and that's what I want to show you, but they are not huge, but still, these are gains. The model is huge, so there are many things that could be discussed, but what you see here is two scenarios, the bold line and the dotted line. The bold line is the scenario where we have this provincial capacity and self-sufficiency constraints. Every province has to have their own capacity to meet their peak load. And in addition to that, we say Ontario goes on with their nuclear power plant refurbishment. And the dotted line is that we lift the provincial self-sufficiency constraint and just have a national one. And what you see for Ontario, so that's the capacity in Ontario, is that by 2030 or even by 2020, Ontario could have less peak capacity, overall generating capacity in Ontario, not by much, but there could be less just because of the possibility to rely on capacity in Quebec and Manitoba, because in the model it's not only Quebec and Manitoba, but I'm just showing Quebec and Ontario. I'm just showing the results for Quebec and Ontario. So there could be less capacity, and only in 2030 there would be a need to have more capacity in Quebec. So that shows some long-term perspective, and this is an optimization model, large-scale optimization model, optimizing a lot of things, not only electricity markets, but including natural gas and other issues, other sectors, but that's what we see. The second result I want to show you is that is about the imports, the Ontario imports from Quebec. In all scenarios, we see them increasing. And this is based, that optimization model is based on the fact that we minimize total cost for supplying energy in all sectors from all sources. There would be substitution between natural gas and electricity. There would be a lot of different substitution. But in all scenarios, there are more imports in Ontario from Quebec, meaning that we have to plan, whatever scenario you're looking at, if you want nuclear power or not, it does only make sense to have more imports from Quebec into Ontario. Now, currently, we stand at about 3 terawatt-hour of imports in Ontario from Quebec. And by 2020, the model says it would make sense to be economic to have 30,000 gigawatt-hour, 30 terawatt-hour of imports from Quebec. And that's what the model says in terms of, what makes economic sense. Of course, current transmission capacity and current policies don't allow for these kind of imports. But if we want to make the best model and then the more economically sensitive model for the electricity sector within our provinces, we need to start planning for these transmission links. Otherwise, we would just make suboptimal decisions that would be costly from an economic perspective and costly from an emission perspective. In conclusion, integration would yield many benefits from an economic and social and an environmental perspective. Socially, there would be some issues. In Quebec, people are very sensitive to prices, electricity prices, especially for low-income households. The good news is that most of these low-income households, they consume very little electricity. So there could be programs designed to meet the issues faced by these low-income households. So I'm not thinking that this is not a problem. It is a problem. It is an issue. We should think about these low-income households that do heat their homes with electricity, and then what we'll do for them. There's something to be dealt with, but it is feasible. Then we also have, I'd like to remind that we already have an energy integration framework in Canada. We have the agreement on internal trade. For more than 15 years, there's been this agreement negotiated every year. There's a chapter on energy. Every year they postpone discussion, and their report on progress on the energy chapter are just non-existent. There are no progresses. But then we already have a framework to discuss that. And it's not the only one. There could be other ones. I mean, greenhouse gases would be another way of discussing these issues. But agreement on internal trade, it is there. It's a platform for negotiations between provinces. The federal government is involved. There would be, I think, this is already there. We should try, I think, to use that tool that is already there to further the discussion. And I'll make a case for more analysis in these kind of issues. We need to make the arguments and then show the data, show numbers to tell people, well, why would it be good for who, and what are we doing for those groups that will suffer from the change. These groups are powerful. In Ontario, we've mentioned trade unions, the nuclear lobby. There are different groups that would suffer. In Quebec, the low-income households would suffer. Very different groups. Governments and policies should be very careful about how they deal with these groups, because these are the obstacles. Thank you very much, and I look forward to the discussion.